Hello all, welcome to another video from B.Sc or B.Tech. So this time we will do a problem from Stokes Theorem. Last few videos were about vector calculus theorems, that is we have discussed Green's theorem, Gauss divergence theorem and Stokes theorem. We had graphical explanation too. Also we had done some problems regarding all these theorems, and here is the last video coming from this vector calculus, that is we are going to do a problem out from this Stokes theorem. Okay. So this particular question is taken from KTU June-July 2017 question paper. Let's read this out. Apply Stokes theorem to evaluate this line integral, and this integration is done along this curve C, where C is the boundary of the triangle with vertices these 3 points. Okay. So we have to make use of Stokes theorem to get the value of this line integral. As per Stokes theorem, here is the formula. Actually Stokes theorem is a relation, or it is a theorem connecting a line integral and a surface integral. See, integral C f dot dr is equal to, actually it is vector f dot dr is equal to double integral S del cross f dot n cap ds, which means this S is the surface which is enclosed by this line, or enclosed by the curve C. Okay. So the question says to get the value for this line integral using Stokes theorem, which means we should not apply this line integral directly. We have to make use of the Stokes theorem, means we have to get the line integral value by taking the surface integral of curl of f dot n cap ds. And what is vector f? All that will be done in this video. So let's start. So the first task is to get the value of the vector f, or what is the vector f. So actually let's compare this LHS and this particular question. That is, here you can see integral C, this complete integrand is actually f dot dr. And you know what is dr? Vector dr is dx I cap plus dy j cap plus dz k cap. Okay, and once you take the dot product of this dr and this particular f, which is unknown, we get the value of this. Okay, so f dot dr, while taking the dot product, how do we take dot product? Dot product is taken by just multiplying the I components, j components and k components and just add them out, isn't it? So vector f must be x plus y I cap plus 2x minus y j cap plus y plus z k cap. Then only, while taking the dot product of these two vectors, we get x plus y into dx plus 2x minus y into dy plus y plus z into dz, isn't it? So this is how we take vector f, and now using this Stokes theorem formula, we have to get the value for this line integral, which means we have to take the RHS side, or we have to do the curl f, then we have to find the n cap, or the unit vector which is perpendicular to ds. I mean, this n cap is actually the unit vector perpendicular to ds. Okay, so we have to get the value for n cap, and everything can be done now. Just see, now we are going to take the curl of this particular function. How do we take curl? Del cross f means it's the determinant of this 3 by 3 matrix I, j, k, and I, j, k components of del is dou by dou x, dou by dou y, dou by dou z, and I, j, k components of vector f is x plus y, 2x minus y, y plus z. So it is I cap into derivative of y plus z with respect to y, isn't it? Dou by dou y of y plus z, dou by dou y of y plus z minus dou by dou z of 2x minus y minus j cap into dou by dou x of y plus z minus dou by dou z of x plus y then plus k cap into dou by dou x of 2x minus y minus dou by dou y of x plus y, okay, which is then I cap into 1 minus 0 minus j into 0 minus 0 plus k cap into 2 minus 1, isn't it? So it is I plus k. I plus k is your curl f. Okay. Now, so we are ready with this term. Del cross f is ready now. Next is we have to get the value for n cap. Actually, n cap is the unit vector perpendicular to the surface S. Now, what is the surface S? S is the surface enclosed by the curve C, and it is given in the question. C is the boundary of the triangle. So, triangle is our surface S. So, let us draw the triangle using these three coordinates 0, 0, 0, 2, 0, 0, 0, 3, 0. Actually, you can see that here the set coordinate is 0 always, which indicates that this triangle is drawn in xy plane. So, I am going to draw an xy plane, okay, and the coordinates are 0, 0, no need to write the set coordinate again, and next is 2, 0, later 0, 3, fine. So, these are the coordinates given and this is your triangle. Fine. So, this is our surface S. Now, how do we get the n cap of this surface S? Okay, this is your surface S. Now, we have to get the unit vector perpendicular to the surface S. See, if you got a surface, you can draw two perpendiculars out from this, that is one out of the screen and P2 into the screen, okay. So, which is your n cap out of this? Both are the perpendiculars and n cap is the perpendicular drawn from the surface. So, which actually is your n cap? So, n cap is chosen like you have to get an anti-clockwise rotation here, which means always if this is your S is surrounded by a curve and curve must definitely have a direction. So, if the curve is having an anti-clockwise direction, then you can choose P1 as your n cap. Okay, when one person is standing there and if he looks at this side, you can see that the curve is making a clockwise rotation. So, we cannot choose P2 to be your n cap. Okay, so always draw the perpendicular for the surface which is having a anti-clockwise rotation of this curve. Okay. So, for this particular surface, you can see that first of all make an anti-clockwise rotation, that is while making an anti-clockwise rotation I had to start from x, then move on to y, then only it becomes an anti-clockwise way, isn't it? So, I start from x, then I reach y. Now, if I draw a perpendicular for this surface, I get a direction along x, y, z direction, z axis. So, n cap is actually k cap, fine. So, that is it, how you take the n cap for the surface S. Now, next aim is to take del cross f, send it, double integral del cross f dot n cap ds is the RHS side of Stokes theorem. So, here it is double integral del cross f is I plus k dot n cap is k cap ds. And actually what is ds? ds is equal to dx dy because S is the surface drawn in xy plane. So, ds is substituted with dx dy, fine. Now, k cap dot k cap is 1. So 1 dx dy, double integral 1 dx dy. Now we have to integrate it. So I have done a video showing the double integration method. So dy, the y ranges from 0 to 3. And what about x variation? So x variation, for that we have to draw a horizontal strip. I have discussed this in the previous video. Must draw a horizontal strip, and the left boundary becomes your lower limit and the right side boundary becomes your upper limit. So left side boundary is here. You have to take both the side equations with respect to x, or you have to get the value for x from both these boundaries. Here x is equal to 0 because it is a y axis. So 0 becomes your lower limit. And what about the upper limit? Upper limit is the equation taken from the right side boundary and get the equation for x. Okay. So this is actually a line. Okay. What is the straight line equation? It is y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. This is the straight line equation when 2 points in that line is given. Okay. So here are the 2 points 0, 3 and 2, 0. So just substitute y1, y2, x1, x2 values from this. Here is your x1, y1 value and here is your x2, y2 value. Okay. Let's substitute and get the value for x. So here is the value for x and that becomes the upper limit for this integration. 2 by 3, 3 minus y. Fine. Now let's integrate this. Let's do the inner integration first. Integral 1 dx is x in the limits 2 by 3 into 3 minus y and lower limit is 0. So substituting we get 2 by 3 into 3 minus y, which is 2 by 3 into 3 is 2 minus 2 by 3 y. Okay. Now moving on to the outer integration, integral 0 to 3, 2 minus 2 by 3 y dy. That is 2y minus 2 by 3 into y square by 2, which is y square by 3 in the limits 0 to 3. So upper limit minus lower limit. 2 into 3 6 minus 3 square 9 by 3 3 and lower limit is 0 minus 0. So the value is 3. So this is the answer for the single integral or line integral x plus y dx plus 2x minus y dy plus y plus z taken for the boundary of the triangle with vertices this one. Okay, this carries about 5 marks. Let me do one extension for this problem, or we are going to verify the Stokes theorem for the same question. Okay, it is not in this particular question, but let us do the verification also. That is, we are going to get the value of this left side of this Stokes theorem, single integral f dot dr. Okay. So for the same question we are going to verify Stokes theorem. Actually we are known with this value, that is 3 is the answer for this line integral. So integral c f dot dr is equal to double integral del cross f dot n cap ds. Actually this value is 3. Now we are going to verify Stokes theorem. That means we are going to get the value of this left side part and we have to check whether the answer is 3. Okay. So for that we need to draw the graph again and get the value or get the curve. Okay. So let me draw. See here, this is your graph, isn't it? Your triangle with coordinates, this and all. Now we are going to take the line integral. Okay, or we are going to do the integration for this curve. So let me split the complete curve C into 3 parts, that is starting from here. Always make a anti-clockwise direction. C1, C2, C3. Okay. Now we are going to do this side, isn't it? So integral C f dot dr is going to be splitted like integral C1 f dot dr plus integral C2 f dot dr plus integral C3 f dot dr. I have done a problem for this line integration. So Let's start from C1. So along C1, give the heading along C1 and let's observe what is along C1. Here you can see the y coordinate is 0, y equal to 0. So since y is a constant value, we can say that dy is equal to 0 because there is no variation in y. And what about x? X ranges from 0 to 2, 0 to 2, okay, which means there is a variation for x, dx is existing. What about z? Because we have to bother about z value also because the question contains the variable z, okay. So just get the value for z. Z is always 0 because the curve is in xy plane. So z is equal to 0 and dz is also equal to 0, okay. Now let's substitute these many values in the question. Okay, so it is integral x plus y, y is 0 here, so x dx, and you can cut off this term and this term because dy and dz are 0. So your integral c1 f dot dr is simplified to integral x dx, and what is the range of x? X starts from 0 to 2. So just take the integration, it is x square by 2, value is simply 2. So first value is got, which is 2. Now we have to get the values for C2 and C3 and add it up and should get 3, okay, that's our aim. Now next part is along C2. Along C2 is this curve, okay. So there you have x varying from 2 to 0, x starts from 2 to 0. So since there is a variation, dx exists and y varies from 0 to 3. So since there is a variation for y, dy exists and z is equal to 0, so dz value is 0. So substituting in your line integral f dot dr, you will get integral, it is actually x plus y dx plus 2x minus y dy, and we can skip the third term because dz is 0. So actually x and y term is there in the integrand, but we have only one integration to be done, which means we have to convert any variable to the other variables, which means the integrand must only contain one single variable, either x or y, okay. So in this curve, we know that for this curve, x is equal to 2 by 3 into 3 minus y. This is the line equation for this curve, okay. So using this equation, let's convert every x variable to y, okay. Also see x can be replaced with this particular integration. So what about dx? X is equal to 2 by 3 into 3 minus y. So what is dx? Take the differential in both sides. It is 2 by 3 into derivative of 3 is 0, derivative of y minus y is minus dy. So dx is actually minus 2 by 3 dy, okay. So using these two equations, let's convert every x terms to y. Then you will end up with so here is the integration after substitution. We can observe that there is no x variable existing because everything is converted to y using these two expressions, isn't it? Now let's write the variation of y. Y ranges from 0 to 3. Now let's integrate. It is negative 4 by 3y plus 4 by 9 into y square by 2, that is y square by 9, sorry 2y square by 9 minus 2 by 3 into y square by 2, that is y square by 3 plus 4y minus 4 by 3y square by 2, isn't it? So it is minus 2y square by 3 minus y square by 2 taken for the limit 0 to 3, okay. So there is only upper limit existing because lower limit will be 0. Every term contains y. So lower limit is 0. Now let's substitute negative 4 by 3 into upper limit 3. negative 4. And 2 into 3 square, 9 by 9 cuts off plus 2. Next, 3 square by 3, 3. Plus 4 into 3, it's 12. Minus 2 by 3 into 3 square. So, minus 2 into 3, minus 6. Minus 3 square, 9 by 2. So, the answer is minus 7 by 2. Okay. So, this is the value for integral C2, minus 7 by 2. Now, let us move on to get the value for integral C3 f dot dr. So, for the next part of the curve, you can see that x equal to 0. So, since x is a constant value, you can have dx is also equal to 0. Now, y ranges from 3 to 0. Y ranges from 3 to 0, which means variation in y exists. And z is equal to 0 implies dz is also equal to 0. Okay. So, these values must be given to this integration. Let us see. So, this is the details for this curve C3, and you can see that dx and dz is equal to 0. So, you will have only integral C3, the middle term, that is you will have only this term, okay, and also x value is 0 there, isn't it? So, you will be left with integral negative y dy, fine, integral negative y dy, and what is the limit along y axis? Y ranges from 3 to 0. So, it is minus y square by 2 in the limits 3 to 0, upper limit minus lower limit, upper limit is 0, lower limit is minus 3 square by 2, which is minus 9 by 2, and value is 9 by 2. Okay. Now, we are ready with the answers. This is 9 by 2. Okay. Now, while adding, we get integral C f dot dr is 2 plus negative 7 by 2 plus 9 by 2 equal to 2 plus 9 minus 7, 2 by 2. Answer is 3. Thus, Stokes theorem is verified. For this particular question, we got 3 as answer by doing separately the line integral as well as the double integral side. So, hence Stokes theorem is proved. If you like the video, please do like, share and subscribe it. Till we meet in the next class, this is Meenu signing off. Thank you and take care.